Hello class, welcome to another lesson. Today's learning goal is I can simplify algebraic expressions with multiplication, division, addition, and subtraction. So far we've learned how to multiply a monomial with a binomial through a process called distribution. We've also learned how to reverse that process through factoring. And we've also learned how to combine like terms, which is addition and subtraction of algebraic expressions. Today we're going to add in division and simple multiplication as opposed to multiplication with a monomial into a binomial. We're going to do that all together to simplify an expression. But before we begin to that, we're going to talk about why 10/12 simplifies to 5/6. And we've always been taught to find a common factor between the two and divide each number by that common factor. What we're actually doing, though, is finding the prime factorization of each one of these numbers and crossing out common factors. So, for example, the prime factorization of 10 is 2 times 5. The prime factorization of 12 is 2 times 2 times 3. So, you can see that they both share a 2. And what this actually equals is the same thing as 2 over 2. Times 5 over 2 times 3. All I've done is bring these 2 and 2 over on the outside. Because remember, when we're multiplying fractions, we just simply multiply across. So if we were to multiply this, we'd get this back over here, 2 times 5, and we would get 2 times 2 times 3. And we know that 2 over 2 is simply just 1. And we know that anything multiplied by 1 is just itself. So therefore, this simplifies to 5/6. What we're really doing is crossing out any common factors that they have in their prime factorization. So, let's take a look at this. This is an expression with variables. And we can see that there are many factors of b at the numerator and many factors of n in the numerator, and the same thing inside the denominator. What we can do with this, in order to simplify it, is to cross out common factors. So this has a b and this has a b, so we can cross them out because that equals 1. Same thing with this b and this b, and this b and this b. We can't cross out this b or this b because there's no b down in the denominator to match it. We have n's up here, we have n's down here. We can cross this n out with this n, and this n with this n, and this n with this one with this one, this one with this one. What we are left with is 2 b's inside the numerator. So that's b to the second power, because b times b is b to the second power. And we're left with 4 n's in the denominator. And to the fourth. It's very important to note that the n's are in the denominator, so therefore they have to stay inside the denominator in our simplified expression. So our simplified expression is right here, b squared over n to the fourth. Same thing for this one. We have a's and k's in the numerator and a's and k's in the denominator. This k can cross out with this one because that makes 1. This makes 1. This makes 1. These k's make 1. And so does these k's. Over here we have a making 1. A and a makes a 1. A and a makes a 1. So therefore we have left over 1, 2, 3 k's and 1 a inside our denominator. This can be written as 1 over k to the third a. And notice how I have put that all in the denominator because this is also inside the denominator. And I've put a 1 at the top because remember, each one of these simplifies to a 1. Okay? Hit pause on your devices and try this one out on your own. So if you do this, you will find that this 5 cancels out with this 5, this 5 cancels out with this 5, this one, this one, this one, this one, and this one, and this one, giving us 1 5 in the numerator. Over here we have a 9, and it crosses out with this 9 crosses out with that 9. All these make a 1, and we have 3 9s in the denominator, so therefore we have our answer of 5 over 9 to the third power, written in exponential notation. What does this have to deal with division of algebraic expressions? Well, here we have something very similar. We have an a at the top and a at the bottom. Okay? and a b squared at the top, and a b at the bottom, and a 12 at the top, and a 4 at the top. Notice how there are two terms here. This is a term, and this is a term. Okay? It's very important to identify what is a term inside these expressions. So we're going to simplify this term first. We're going to simplify starting with the numbers in the numerator and the denominator. 12 fourths is the same thing as 3. Now let's take a look at the variables. We have 1a at the top, 1a at the bottom. Those cancel out. We have 2a's at the top, 2b's at the top, 1b at the bottom. So therefore, there's going to be 1b left over. Once we cross out, we get a single b. We put our subtraction sign in. Let's take a look at the second term. We have a 6 in the numerator, but nothing in the denominator, so we don't have anything to cancel out with it. Or to simplify it, we have 6. Then we have an a and another a. Those cancel out, which leaves us with just a b, leaving us with 3b minus 6b. These are like terms, so therefore we can simplify that by 3 minus 6. We get negative 3b. Our final answer is negative 3b. Let's take a look at the next problem. In this problem, we have 4 terms. This is a term, this is a term, this is a term, and this is a term. So let's simplify each one of these terms. We have 8y squared. There's nothing to simplify inside that one. 5x times 4. Well, here we would simply take the 5 and the 4, those are the number parts, and multiply them together. This becomes 20x. We'll keep the x because that's part of the first part. This second one over here, put a minus sign. 2 times 2 is 4. Y times y is y squared. Minus sign again because there's a minus sign right here. 40 divided by 10 is 4 with the x, and then we also include this 8y squared because that was already simplified. Now we're going to combine like terms. I'm going to change things to addition of the opposite and rewrite this so that like terms are next to each other. 8y squared plus negative 4y squared plus 20x plus negative 4x. And once we combine like terms, 8 plus negative 4 is 4y squared. 20 plus negative 4x, or 20x plus negative 4x is plus 16x. And we have no more like terms, and each term is fully simplified, so therefore this is our final answer as the simplified expression. Let's try this one over here. We have a 25ab cubed over 5b squared as our first term. This is our next term, and our final term over here. In this first term we have 20 over 5, which in fact is 5. We have ab to the third and b squared. 2 b's cancel out, so we have a b as the variable part simplified. 6 times 7 is 42, and a times a is a squared. With the addition sign down, we have 144 divided by 2, which is 72. A cubed divided by a is a squared. And finally over here, 8 times 2 is 16, with a times b, which is simply ab. We're going to move, change this into addition of the opposite and move like terms next to each other. We have 5ab plus 16ab plus negative 42a squared plus 72a squared. We combine like terms. 5 plus 16 is 21, so we have 21ab. Over here, negative 42 plus 72 is 30. And then we have 30a squared. And that is our simplified form. Try this last one on your own and hit pause on the video. This first term is right here, the second term is right here, third term right here, fourth term is right there. Over here we have 8 times 2, which is 16 am, plus over here we should have 45 p.m. 88 divided by 11 is 8. We have an a p.m. up here and just a right here, which cancels out the a. We have 8 p.m. And over here, 24 divided by 3 again is 8. A squared, m squared, 1a cancels out with this a, 1m cancels out with that m, and so therefore we have am. I'm going to change this to addition of the opposite, and then move like terms next to each other. We have 16 am plus 8 am plus 45 pm plus negative 8 pm. And once we combine like terms, 16 plus 8 is 24 am plus, and here 45 plus negative 8 is going to get us 37 pm. And that is our simplified expression. Go ahead and try the worksheet on your own. Please ask me if you have any questions, and have a great break.